Okay, so again, we're dealing with f of x, which is x squared plus 1, and g of x, which is x minus 3, and we're finding this composite function, and that just reads, again, f following g is what this part right here means, okay? F following g. So if f is following g, that means we're going to take that g function, the one that's on the inside, okay? This one right here is going to be put in place of x into the f function. Okay, so that means I'm taking the entire g function, this x minus 3, and I'm putting it in place of x into the f function. Okay, f following g. So in the f function, it is x, the whole thing squared. So in place of x, I'm putting that entire g function. So I'm putting that entire x minus 3 in place of x. I'm going to square it. And then I'm going to add 1, and I forgot something. We'll have to go backwards in just a second. Okay, so the letter on the inside is going to be, that entire function is going to be put in place of x into the letter on the outside or on the front part. Okay. And what we're going to do is we're going to work this out. However, I forgot, my bad, got to go back, Monday brain, is we need to look at each function individually and determine their domains. Because when we deal with these composite functions, a lot of the times there are restrictions. They might simplify out as we find the composite. So we have to always keep those in consideration. So let's go back and take a look at the function f. If my function is x squared plus 1, does that require any restrictions? No, because there are no fractions and there are no radicals. Okay, so the domain for the f function is just going to be my all real numbers, negative infinity to positive infinity. And then what about g? Does that one have any restrictions on it? No. Okay, so that one is also going to be negative infinity to positive infinity. Is everybody okay so far? Now, what I need to do is I need to finish simplifying what I did. I took that g of x function, the x minus 3, and I put it in place of x into the f function. So now I have in parentheses x minus 3, but the whole thing is squared. So what do you think I need to do with that? I need to square it. I need to multiply it out. So what we're going to do is this, is we're going to take that x minus 3, we're going to write it twice so that we can FOIL it out. And then that plus 1 is still there on the outside. So what I would like for you to do is go ahead and take a minute, FOIL out x minus 3 times x minus 3. You still have that plus 1 on the end that you'll need to then combine terms once you're finished FOILing it out. Once you distribute it, you're going to combine your like terms. The result will be the composite function f following g of x. So we're just going to do like we know how to do, distribute each term. And then I'll just combine my like terms. So that's going to be x squared minus 6x, and then I can combine those two together to get a plus 10. Okay, and so that would be the result of the composite function. And then what we want to do is take a look, keeping in mind any restrictions that we had in the beginning, which we didn't have any. It was all real numbers, so that's okay. Would this composite function require any restrictions? The x squared minus 6x plus 10. No, no fractions, no no radicals, so therefore it is going to be a domain of all real numbers. So two-part answer, the composite function and then the domain of the final thing. Anybody have any questions so far? What a domain is. So the only time we're going to have restrictions on our domain is if we have a fraction, which I don't have, and then if I have a radical, which I also don't have. So since I don't have either one of those, then I can use it. Anybody have any other questions before I move on? All right. Same two functions, so you don't need to rewrite those, but we're changing our composite. We're doing it this time with G following F instead of F following G. Okay, it's the same two functions, the x squared plus 1 and the x minus 3. Again, we want to think about the domain of each individual function first, in case when we do the composite, any part of it simplifies out. But we just did these domains. Does F have a restriction? No. Okay, so though that can't talk. That domain is going to be my all real numbers again, negative infinity to positive infinity. What about the g of x, x minus 3? Does that have any restrictions? No. Okay. So far, that part has been relatively simple. Nothing to worry about. And again, we're going backwards. The whatever letter is closest to x, that entire function is going to be put in place of x for the first function. So we are going to take the entire f function, the x squared plus 1, and it is going to go in place of x into the g function. So if I take out that x, I'm going to replace it with x squared plus 1. That's where the x was. And then what's behind it? Yeah, negative 3. Okay. This time I don't have to worry about multiplying because it's not squaring anything. It's just putting it in place of x here. But I do have some terms that I can combine. What would that end up with? X squared minus what? Minus 2. Okay. So that would be the final for the composite. Would there be any restrictions in that part either? No. Okay. Everybody okay so far? All right. Two new functions. Take a minute and write those down. F of x and g of x. We're going to find both composites here. This one is going to be a little bit trickier. Start with your domain for f. Before we start trying to do the composite, let's look at the domain for each one individually. So if I'm looking at f, do I have a fraction or a radical here? Yeah, I do. I have a fraction. So there is going to be a restriction, something that x is not allowed to equal. So we're going to have to keep that in mind when we go to our final product or our final composite here. What is it that x cannot equal that would make that turn to 0? 1. Okay. So if x can't equal 1, it can be everything but that, right? So that domain would be from negative infinity to positive 1. And then again from 1 to positive infinity. Okay, it can't be 1. That's how we write the domain when it can't be 1. And then if I look at g of x, another fraction, what would I put in place of x here that would make that turn to 0? If it's just x, what's the only number I can turn to 0 with? 0. Okay, so in this one, x cannot equal 0. So the domain would be negative infinity to 0, and then 0 to positive infinity. So what we're going to need to keep in mind, no matter what the result is when we do this composite function, which two numbers am I not allowed to use? 0 and 1. Okay, so when we do our final domain, we're going to have to keep those in mind. Sometimes it's the same, sometimes it's not. Everybody ready? This part's a little trickier. All right. With the first one, we are going to take the entire g function and put it in place of x into the f function. So I'm going to take this entire fraction, 1 over x, and I am putting it in place of x here. Okay, so the f function is 1 over, but in place of x, I'm going to put my fraction 1 over x. And this one's going to be a little bit tricky. That's a fraction inside of a fraction. Are we allowed to leave those? No. Okay. So in this case, because my denominator has a fraction in it and it's part of another fraction, what I want to do is I want to simplify that part first. Everybody ready? All right, I'm going to, just for the sake of the video, I'm going to have to put it over here. So we're focusing on this part right here. I'm just going to come over to the side and do this. In order for me to add and subtract fractions, what is it that I have to have? Common denominator. Okay. What's the denominator of my first part? X. So if I need to turn that second part into something over x, first part's not going to change. Think about 1. What is it over always? 1. So how am I going to turn that into something over x? What do I multiply x by to turn it into, what do I multiply 1 by to turn it to x? X. So we're going to do the same thing to the top. So now I have the same denominator. I can do what it tells me. It says 1 minus x over x. Are we kind of okay with that part so far? Subtracting fractions? No? Okay. No, that's just part of it. I didn't keep going because everybody told me no, they didn't understand where I got it from. All right, so we got our fractions 1 over x, and we want to subtract 1, but you got to put that together. So we first want to think that that's 1 over 1. It's Monday, sorry. To get the same denominator, we're going to use x. Okay. So that first fraction doesn't change. To get this one to turn into x, to make that do that, I have to multiply it by x. That means I'm going to have to do the same thing at the top. So 1 times x gives me x. Does that part make sense? Then to bring it together as one fraction so that I can keep going with my problem, I just take the numerators, 1 minus x, and I keep it over my denominator of x. Kind of okay? A little bit. Okay. Now what we're going to do is we're going to take that and put it in place of this right here, because that's what I just simplified, right? So now it's going to be, 1 minus x over x. Boy. Still not allowed, right? Fraction and a fraction. Do y'all remember how we dealt with complex fractions at all? We've already done this. All right, let's do it the old-fashioned way. What does the fraction bar mean? It means to divide, right? So we're going to take that top part, 1, and we're going to divide it by that bottom part, 1 minus x over x. And when we divide with fractions, what do? We keep the first. We change the division to multiplication, and we flip. And so then if I multiply 1 times x over x minus 1, what does it just give me? X over x minus 1, right? If I do this, if I multiply 1 times that fraction, 1 times anything remains the same, right? Yeah. So my most simplified answer of this composite function is just going to be this part right here. X over x minus 1. So that's the first part of the answer. Kind of okay. A little bit harder, but not impossible. All right. And then let's talk about our domain. Looking at my new composite, are there any additional restrictions to that? What did we say in the beginning we couldn't have? What's the number? 1 or 0. So can this, does this add an additional restriction, or is it one of the same that we've already said? What can X not be in that function? 1. So that's one we already said, correct? So think about this. Let's think about our number line. What's bigger, 0 or 1? 1. Okay, so 0 goes on the left, 1 goes on the right. We can't be 0 and we can't be 1, but we can be everything in between, right? So we can be here, which would be negative infinity to 0. And then we also have another interval that we can combine with that, and that would be everything in between 0 and 1. But then we have that third part as well. So it can be also everything past 1. So my final domain, we have to include the 0 because the 0 is one of my restrictions. You cannot lose that because it can cause you to get an undefined function. So my new domain is that for the final function. The two restrictions together that we had in the beginning. Y'all are looking at me like I'm crazy. Does that make a teeny tiny little bit of sense? Okay. All right, we ready to go the other direction? Yeah. You just gotta just take it one little step at a time. All right, so we're gonna do this. We are going to erase my stuff. Go back to my two original functions, but for my second composite, I'm taking f and putting it in place of g, correct? Okay. So let's take the entire f function and put it in place of x here. Okay, so my g function starts out with 1 over, but in place of x, I'm putting this entire piece, right? So that's going to be 1 over x minus 1. Okay, let me ask you a question. Do I need to simplify this part like I simplified that part first? No, this is already combined as one fraction, right? This one had a fraction minus a number, so we had to simplify it. So let's think like what we did the last time. I still have a complex fraction. So what I can do is think about it the old-fashioned way. It is going to be 1 divided by, so top part, divided by bottom part, which turns into 1 times the reciprocal, which is just going to give me what? Could we just, oh, that wrote funny. You can leave it as x minus 1 over 1. Could we also just leave it as x minus 1 if my pen would write properly? Either one of those would work. right, and then would our domain be the same? Would we still have to include the restrictions there? Yeah, so the domain is going to be the same as this one because you had your two original functions and part of it disappeared. Now it's going to try to work. Huh? I'm not going to take up space, but it's the same domain there. Okay, this one is not as difficult. I would like for you to try this one, okay? This one's not going to end up with fractions inside fractions. I want you to try this one. Do the F following G and then do G following F. It does have one fraction in it, but it's not going to be as difficult as the last one. Be careful with the F following G with the domain of it. So closest to the X is the one that's yeah. Don't forget to consider the domain of the original two functions. What's the domain of the original f function, what can x not equal for that one?
4. Okay, so that domain, x cannot equal 4. So it would be negative infinity to 4, and then 4 to infinity. What about g? Does it have any restrictions? No. Okay, so that domain would be just all real numbers. So for the first one, we're going to take g and we're going to plug it in place of x into f. So I'm going to take this 5 plus x, and I'm putting it in place of x for that function. So it is going to be 3 over, but instead of x, I'm putting 5 plus x, and then we have that minus 4. That's just a matter of combining terms, right? So that's 3 over, what do I end up with at the bottom? Say that one more time. 1 plus x, yeah. If you combine the positive 5 and the negative 4, that gives you a 1. You could also put that as x plus 1. It would be the same. That would be your final for the composite there. Okay, so either 3 over 1 plus x or 3 over x plus 1. Does that add another restriction here? Yeah. What can x not equal in this one? Negative 1, okay? So we not only have to include the 4 from before, but we also have to include that negative 1. So think like we did with the 0 and the 1. I cannot be negative 1 and I cannot be 4. So that will be negative infinity to negative 1. And then negative 1 to 4. And then 4 to infinity for the domain. Are we kind of okay with that one? Now, when you do the other way, when you do g following f, you will have to get common denominators to be able to combine those two pieces together. I want you to keep working on it. You're going to go backwards. You're going to take the entire f function and put it in place of x into g. You will have to get common denominators. I want to kind of get some of you started because some of you are on the right track, just kind of stuck. Let's take f and put it into g. So this whole f function is going to be put in place of x there. So it is going to be 5 plus that entire f function. And then I saw some of you doing this, which is the perfect next step. If I want to be able to add those two together, what denominator does that 5 need to have? X minus 4. Okay, so what we're going to do is we're going to multiply the top and the bottom by x minus 4. So make sure you're distributing there. So that'd be 5x minus 20 over x minus 4 now. Now you can finish it. Add the two fractions together, combine any like terms that you need, and then check out the domain. Did it add any other restricted values besides the 4 that we started with, like the first part, or is it just going to keep the 4? what you got is perfect. Uh-huh. So in the last question, when I simplified it and got the 3 over 1 plus x, that gave me another restriction because I have a new denominator, that 1 plus x. But in this one, did you have, what you were said in the beginning, that couldn't be 4, right? So that's not an extra. This is. All right, so when I add these two together, 5x minus 20 plus 3, what do I end up with? 5x what? Minus 17 over x minus 4. So that is the simplified composite function. Looking at this, look at my denominator. What is my restriction for this one? What can x not equal? 4. That was what I already had before, right? So I didn't add an extra one. So the only thing I can't be now is 4. So we're going to write that domain. I can go from negative infinity to 4. And then again from 4 to positive infinity. Okay, it did not give me an extra restriction like the first part did, so I didn't need to include another number. I just used that original one that I didn't have, or that I had, sorry. Make just a little bit more sense. Okay, we got one more to try. Everybody ready? That way? This one right here, circled. Yeah. So it was the negative 1 and 4 because of this piece right here had that negative 1 added to it. Does that make sense? Okay. All right, last one. F of x is just the absolute value of x. G of x is 2 over x minus 3. While you're working, question, does the absolute value give you a restriction? Have we ever talked about absolute value giving us a restriction? No, we just talked about fractions and we talked about radicals. So the absolute value of x does not give me any restrictions. I can put any real number in and get any real number out. Also, I'm going to change our homework too, just FYI. I'm going to cut it out because there's two questions per problem, so we're going to go to just 15. So that's technically only 6 things that you have to do instead of 2 more. Yeah, so it would be the same as the restrictions for that one. Except for when you do this, you start negative 1, negative 3, and negative 3. So that takes care of the whole left side and the whole right side. That's all good. You don't, you just put it in place. So you just take this x out. What's the domain of f, the original function? If it's just the absolute value of x, what did we say? That has no restrictions, so it would just be all real numbers, okay? What's the restriction going to be on g of x? What can I not equal? 3. So it's going to go from negative infinity to positive 3, and then again from positive 3 to infinity. And we're going to start by taking the entire g function and putting it in place of x, which basically just means we're just going to have the absolute value of the fraction, right? Nothing else I can do to simplify that. Did it add any different restrictions to my domain? No. Okay, so the domain is going to be exactly the same. So that's the composite function, and the domain is going to be what it was. I just can't have 3. And then we're going to go backwards. We're going to take the entire f function and put it in place of x into g. So that's going to be 2 over. This time it's just the absolute value of x and then a minus 3 behind it, right? I took out the x that was in the g and I replaced it with the f of x, which is just the absolute value of x. Now, we know we can't use 3, right? Think about what we have there. If I take the absolute value of a number, I'm just taking its distance from 0, which is always what? It's always positive, right? So could I put another number here that would also result in 0? We could put positive 3, but we can also put negative 3 in there, right? Because the absolute value of negative 3 is positive 3, which would then give me 0. So in this case, I am adding another restriction. I can't equal either one, negative or positive 3. So think about what that would look like in interval notation. What can I not equal? How many different parts am I going to have? If I have 2 different restrictions, I'm going to have 3 parts. So we're going to go from negative infinity to what's my smaller number, 3 or negative 3? Okay. And then in union between negative 3 and positive 3. And then the last one would be from 3 to infinity. So there's the domain, there's the simplified composite function. Okay, and just make a note, because I should be able to change it on Canvas, but in case I don't get to it till later, just make a note on your homework. You're doing just through 15 odd, not through 19 odd, and it's the same page as Friday, 294. Okay, this is a little bit more challenging than before. Just take it step by step. So again, 11, 13, and 15. You're going to do both g of x and, f following g and g following f.